Okay, so data centers, I mean, by almost by definition, they're not very green. They consume substantial amounts of power, as our friends on Panorama pointed out the other week, etc. So is it helpful to talk about green centers, or should we be more realistic and honest and talk about sort of environmentally optimized data centers? Or does the terminology actually matter?
Well, so does the terminology matter? I'm not sure. I think we mustn't forget the environmental benefits that digital services deliver in the first place, right? So, when we take paper processes executed by people in offices and turn them into a digitized automated system that ultimately not only saves the paper, but the effort involved in doing it speeds things up, improves time to market or time to value for whatever the process is. We move the human race forward in terms of performance, and that can have massive environmental benefits. So looking at the data center ecosystem on its own and saying it consumes a lot of power, yes, it does, and we'll absolutely get into that. But I don't think we should ever forget that the services that are offered out of data centers in terms of digital technology are actually very often performing huge environmental benefits on the front end, right? So that would be the first thing I would say. With respect to data centers themselves, yes, they consume a lot of energy. They're getting more efficient. Has there been greenwashing of data centers, as there have been of many other systems, processes, businesses, organizations, topics in the last 10, 15 years? Yeah, definitely. That is something that we need to work through in terms of separating out what are the tangible measures and benefits that we can actually deliver on, and what is really just hiding a problem. Does the terminology help us do that? Maybe.
Okay, and in terms of sort of where we are at, I mean, I've been in the industry quite a while. I expect you have. The initial talk was all about carbon offsetting. We're going to plant a load of trees to compensate for the amount of energy we're consuming, carbon we're putting out, and stuff like that. That was fairly crucial. And even you could argue that licenses saying you're buying renewable energy, because obviously the stuff that comes down your pipe, you've no idea where it came from, really. So but are we getting more sophisticated now? So that was the sort of first easy sort of demonstration of data centers. Look what we're doing, aren't we great?
Yeah.
But now they're actually doing some more sort of complicated but meaningful processes, if you like, to become significantly greener, more sustainable.
Yes is the answer, and a few examples. So the concept of buying green electricity on a market that is fed by multiple different sources really doesn't guarantee you anything, other than a bit of that money goes towards renewable sources in the future. There are now a number of data center providers who have set themselves up with their own, with a dedicated green energy source available to them, right? And so we have customers in the UK who have deliberately chosen to put data center services into Iceland, for example, where they have lots of geothermal power and hydropower, and in fact are pretty much 100% renewable. So they know the power that's going into that data center is from a renewable source, and have made that decision deliberately in order to make sure that that's the case. So that's the first thing. I think beyond that, the technology itself is getting materially better. As more and more data centers get comfortable with liquid cooling of one sort or another, and I'm sure we'll get into that in more detail as we go on. You can bring the PUE values down significantly, and manage the carbon that they're generating massively. I think the first significant step was moving to some level of DLC. Now, as we start to see immersion cooling getting a small foothold, I think we get even more efficiency. Plus, the technology itself is getting way more efficient too, in terms of the intelligent smarts that we're putting into them, in terms of our ability to ensure that they're utilized, and actually just at silicon level, the power consumed for the work done is getting more and more efficient as well. So I think we are moving in a more positive direction. Of course, actually, as more companies and organizations and business processes go through that digital transformation, we're putting more and more into our data centers as well. So yes, we're getting more efficient. Yes, we're starting to see some real improvements, but of course we're using them more too. So net, are we keeping up with the growth? Probably not quite. We need to keep innovating and moving forward.
And in terms of sustainability, I mean, the point you make there is accurate, because we can't particularly retire legacy data centers, because we do actually need them, as you say, because the explosion in digital transformation. And I'm guessing it's much more difficult to make a 15-year-old data center truly sustainable than you've got a nice greenfield site. Theoretically, there's no excuse not to build a fairly sustainable, environmentally optimized data center. So how does the industry sort of wrestle with, is it possible over time, do you think, to retire all the legacy, or just because of the demand, we just have to do as best we can with those, whilst also ensuring that new builds do the job?
I think we have to be retiring the legacy, and actually it's sort of forced upon us in some respects. So, and it might well mean a refit rather than a retirement in some respects. So let me give you an example. Right? If you go back, I want to say 10 years, most data centers were running somewhere between 3 to 5, maybe as much as 10 kilowatts per rack in terms of compute load. They would never really go beyond that. We now see data centers or systems calling for over 100 kilowatts a rack. So just to get that power density, let alone the cooling density, into a data center facility requires a complete refit, right? So these old facilities running old technology, fine, but as that technology becomes obsolete and is replaced, you can't put the new technology into it without creating all sorts of new issues, because you can only fill your racks a quarter full, because you can't load them up with new servers and storage. So actually, to some extent, the progression of core infrastructure load and the requirements that it has of the environmental space in which it's operating is forcing some of those data centers to remodel, refit, or retire. So while the physical facility might stay the same, most of them are having to completely recable, find new power sources, regenerator, build new HVAC systems as they go, because the reality is that the services that they're offering out from them, as the technology is refreshed, have far greater requirements than were ever really foreseen when that facility was built.
Yeah, and you mentioned customer moving to Iceland. There seems to be a growing trend for the Nordics for the obvious reasons around renewables, temperatures, etc. Do you think that is a sustainable, perhaps a bit of a pun, but do you think that is a serious sort of trend that's going to accelerate? I mean, we understand that if you're in the city of London and you're trading, you probably can't afford to have your data center that far away from your application. But for most of us in most of our applications, whether our data center is in London or Oslo or Reykjavik, doesn't make a massive difference. Are people beginning to realize, therefore, that if they want to be more sustainable, data center location is perhaps more important than they've traditionally thought?
Definitely, and I think the infrastructure that allows more and more services to take advantage of it is improving too. So there's a new undersea cable being commissioned this year between between Ireland and Iceland, which will massively reduce the latency between the UK and Iceland, specifically if you wanted to run trading services, for example. It probably won't be good enough for some of the electronic markets to run, but it will still be significantly better than it is today. So we'll take a round trip to Iceland today, which maybe is 20 to 25 milliseconds, and that will come down to about 8. And so that's a big step forward, and that will enable more services to move through that process. Now, there's also aside from the data sovereignty issues of moving data to other geos, which clearly organizations have to deal with, there's also the fact that if your services run from a different locale, you are effectively exporting cash. So I think governments will start to get involved as the as they see cash flowing out of centres like the UK or London, to the Nordics, specifically to deliver electronic services back into the UK, at some point regulation will get involved beyond the data sovereignty issues, because they'll look at the GDP impact of that, right? Which will eventually become significant. So is it a long-term solution? Yes, I think it probably is, but I don't think it's the only solution. I don't think it will work for everything, because there will ultimately end up being some regulation around it, because running data centers is an expensive business on many fronts. Actually, while there is plentiful supply of renewable energy in some of those Nordic countries, it's not unlimited. And while when the rest of Europe catches up, I think you'll see some competition for that industry to come back to mainland Europe and to the UK. And to some extent, we're already seeing that. There's investment going in now to new data centers in the UK that won't be online for a few years yet, but will ultimately be designed to bring back some of those services. So I think we'll see the need of the pendulum swing and probably swing back again.
Okay, but even within a country like the UK, I mean, for example, Scotland might be a more obvious place to put some data centers which aren't, latency and millisecond sensitive.
Yeah.
Do you think that's the sort of thing that individual countries might therefore explore the best part of their country where to build data centers?
Yeah, I mean, the best place, if you were to do it on a clean sheet of paper with no restrictions, the best place for a data center is next to a power station, right? That's really where you want to be. And so as we think about the energy future of countries like the UK, and there's lots of talk about that in government and politics at the moment, we should be thinking about where we're going to put our data centers too. So as we think about, what does the future include in terms of renewable energy sources? Where do we go for the next nuclear? Are we thinking microgeneration or a couple of new very large plants? And how do we then consume that energy in the most efficient way? I think is a question that isn't really making public discussion, but is definitely on the minds of some of the decision makers.
And we would reference, you've referenced renewables a couple of times. So it's clearly part of every data center's on its wish list. And as you say, there are some sort of, I guess, provable dedicated supply lines, but those are few and far between. And we all know the problems with wind and sun, how reliable or otherwise it is. But we've got things, the lithium-ion batteries, the hydrogen fuel cells. I'm talking to someone next week that claims that hydrogen's the main power source of the data center. It uses zero water, zero UPS. I mean, I haven't talked to them yet, so I'd be interested to find. So how innovative can we be around? And there's the hydro-treated vegetable oils, I think, as well. So there's lots of things sort of bubbling under the surface. Do you think they will become more mainstream, or can we never get away from the fact that whether it's coal or gas, depressingly, that's the most reliable form of power, and as data centers need very reliable power, we're stuck with that?
I think we will get to a point where we can be on renewable sources. We do have the peakiness of solar and wind and even wave technology to some extent, that requires you to have a storage mechanism in the middle. But data centers have run for years with UPS and some level of local generation. We now have generators. There are megawatt level generators that are using biofuels and vegetable oil and so on. So there are already circumstances today where a data center can come off grid. And in fact, that was part of the government's plan over the winter in the event that we were going to face supply issues from a domestic energy supply point of view. They would ask some of the data centers to flip over to backup generators in order to reduce the load on the grid and allow domestic properties to continue to receive energy. I actually think the answer, though, is that, and I'm no expert on battery technologies or hydrogen, so those are not my area of expertise, but I do think batteries play a big part of the future. I actually think batteries play a bigger part in domestic supply than they do in data center supply, but by managing the domestic load more effectively, and particularly the peakiness of domestic load, you then allow the data center supply, which is relatively constant, to be part of a bigger part of the whole than it is today. So a data center power utilization graph looks pretty consistent, right? It's relatively flat. It might go up a bit during the day as some of the services get more active and then die off a little bit, but it's generally speaking, it's pretty consistent. Whereas domestic supply, as we all know, spike in the morning, nothing during the day, big spike at tea time, nothing overnight. You've got to remove those spikes, right? And whether they're done on a grid level or a small community level or an individual property level, if we can take those spikes out using batteries, that's how we make better use of our total grid generation capability. And actually, that's how we'll be able to move away from some of the oil and gas fired power, because we won't need something that is that spiky. We'll have enough resilience in the distributed network from a battery perspective that will allow then the generation from solar and wind and everything else to go up and down, but the resilience is built into the consumption side, which actually means that we don't have too much of a problem anymore. Obviously, lots of investment required from lots of different parties to get there, but I think that's the direction we'll end up going.
Okay, and liquid cooling, it's not a new technology. If you talk to the people, know these things have happened way back when, I think, but it's obviously got a renewed impetus now. Although there are various, I think it was a Microsoft project, dumped a whole data center in the sea. I know it was obviously a sort of trial rather than for real, but that's sort of one end. You dump the whole data center underwater to, I guess, perhaps where people like Dell are more interested, even at the chip level, you're cooling, and there's sort of various bits of cooling in between. So how do you see the liquid cooling? And as I understand it, for many of those options, obviously retrofitting is a bit of a problem. So again, back to this sort of got an existing data center, it's not very easy to incorporate liquid cooling, but obviously if you're building a brand new facility and new servers with on-chip cooling, for example, what are the opportunities, I guess, with liquid cooling?
Yeah, so there's three major buckets of liquid cooling technology today. So at the most basic level, and the one that you can relatively easy, is more possible to fit to an existing data center. You can do things like liquid cooled doors on your racks. So literally putting a radiator on the back of the rack. So as the heat passes through it, collects the heat and takes it through the facility water. That can be done quite easily using standard compute load infrastructure that's already there. Literally just change the doors on the racks and run your facility coolant to it. And there's plenty of data centers today achieving pretty decent PUE values using that technology. So that's live, running. There's many vendors in the market, lots of people doing it. Beyond that, you then go to DLC, which then moves you further in terms of efficiency. So direct liquid cooling of CPU at first port, but also GPU and in some cases RAM. Heat exchangers on the chips, pumping facility chilled fluid through that to take the heat away and extract it that way. And you can get down to, about below 1.2 using DLC, down even as under 1.1 in some cases. So it's pretty good. It's definitely better than air cooling. It certainly makes for a better environment in the data center. You don't have to worry so much about forced air flying around. You don't have to worry so much about noise. It's quiet. So there's a lot of advantages to it. Obviously, it can be expensive if you're having to retrofit an entire data center. But if you've got chilled fluid already available, then it's a great option. And actually, we have that from a portfolio perspective. Most of our new servers now have that available as an option across the range. And then the area that I think is getting really interesting now, and is still not yet mainstream, but is coming, is immersion cooling. Literally, and to your point about Microsoft, right? They took the whole data center and dropped it in the sea. Well, this is effectively having a bath of inert fluid, non-conductive fluid, and you drop the servers into the bath. So they have to be modified in order to work in that environment. So you have to take all the moving parts out. You can't have fans, you can't have spinning drives. So it has to be a purely solid state server or storage environment, and then you can drop it into the fluid. The fluid is circulated within the bath, and then the heat is taken out via a radiator or a heat exchanger. Now that on its own, you go, okay, well that's interesting, but is it that much more efficient than DLC? And there's expense to it, and servicing becomes a problem, and so on. All true. However, what you can also do with this is you can use the heat. So you can use the heat to do something else. And we have a number of customers and projects kind of kicking off at the moment where they're looking at ways of utilizing that heat to either heat buildings or heat swimming pools or some other facility that needs heat from a data center that really doesn't need heat, right? You're trying to extract heat all the time. So we've got some very interesting projects going. And if you calculate the PUE of the entire system, you're down below 1 because you're using the generated heat to heat something else that you would have had to draw power from the grid, for want of a better term. It could be gas supply, but in order to heat it. So you start to get some really interesting symbiotic projects that may not have existed before. So, for example, we have a number of local councils looking at whether they can heat municipal swimming pools by moving their data center into the empty building that's now next door to the pool, putting it in a liquid called immersion cooling bath, and then using the waste heat to heat the swimming pool. And that, of course, is a fantastic opportunity for them from an efficiency point of view, but also for the industry as a whole. So it's still relatively early stages. There's still lots of prototyping going on, but it's an interesting part of the market for sure.
And in terms of a lot of what we've talked about, the sort of, I guess, the managing of it, the operation and the management is crucial. And I'm guessing sort of automation, AI, which again is becoming more mainstream across a lot of industry sectors. I know DSIMs have existed for a while with varying reviews, but fundamentally AI is in its infancy in terms of how well it can control the whole data center environment. Is that right? And again, what do you see as the potential to help improve the overall performance of a data center?
Yeah, so I think AI running the whole data center, I'm not sure we're there yet, right? I don't think we have a system yet that is smart enough to integrate the building management system, the HVAC, and the onboard telemetry from all of the IT load to be able to manage the whole system as a whole. However, each of those systems individually is getting much better and much smarter. So if I think about the servers and storage, which is obviously our area of expertise, we have smarts built into the systems now, which manage the power far more effectively than they ever did before. So we will do things like turning fans all the way off in some cases, but certainly turning them up and down to manage hotspots within the server itself, and then also to manage different intake and exhaust temperatures. So you can set in the open managed console, you can set what you want your exhaust temperature to be, and it will manage the server to that. So you can then tell your BMS the exhaust temperature is going to be this, and it can manage the HVAC system to deal with that particular heat load. And so you can, while the systems aren't necessarily linked, you can effectively manage them because we've got enough smarts built into the system to control the heat going in and out. So I'll give you a real example. We do a lot of work with Cambridge University, and we looked at the efficiency of their GPU cluster that they were building. And we effectively turned down the speed on some of their GPUs, and we saved 40% of the power consumption for 10% of the performance hit. So by turning down the chips to 90%, we actually save 40% of the power on those GPUs. And when you think they're 300 watts a slot, and there are hundreds of them, that's a lot, right? We saved just by being smarter about how we're using the technology. And we would then actually play that forward into the open managed system so that we then told the server these chips would turn down, and we're going to therefore produce a lot less heat. And so the whole server's throttled down their requirements in terms of heat management and so on. So it made massive knock-on savings through the whole of the machine by making that change. And we have automated processes in OpenManage, so you can just basically pick a target temperature or pick a power level you want to go to, and it will manage all of the servers in an environment to that level.
And in terms of, I mean, reference PUE a couple of times, the one is the assumed, unchangeable IT load, but
yeah,
a company like yourself, I'm sure will tell me that is changeable, and you're doing things. We've mentioned, well, you mentioned, sorry, several things, but in terms of the fundamental way that storage servers, etc., operate, I'm no expert, but I'm told photonics is a potential sort of future game changer. But what sort of things are companies like yourself able to do with the hardware to help contribute towards this sustainability roadmap?
I think the single biggest thing you can do, or we can do, is use less of it, right? So if we can literally put less hardware into a data center to do a specific job, we will save energy, power, carbon, whatever measure you want to go to. And that will always be the single biggest thing you can do. So technology advances inside the equipment, fine, great, fabulous. We need to do that. We need to get more efficient, but we're tweaking around the edges. If you can deploy less of it in the first place, that makes the single biggest difference. So, for example, storage platforms that consolidate your data and do data deduplication, so you don't have to keep the same piece of data more than is necessary. So we offer on several of our platforms a data data reduction guarantee, where we will say you will compress your data at least 4:1, which means you need 25% of the drives that you would have needed if you don't do any compression and deduplication at all. Now, SSDs or NVMe drives versus spinning drives, power is very different. But if I can deploy only 25% instead of 100%, I will make the single biggest difference you could possibly make, because I've only deployed a quarter of the amount of technology that I needed to in the first place. Same goes for technologies like virtualization. The more you can consolidate onto fewer servers or fewer systems, the more energy you save. So yes, we're doing tons of stuff at a hardware platform level, and happy to send you information on that if you're really interested. But the single biggest thing we can do is help our customers be smarter about deploying less technology in the first place, right? And that's about picking the right technologies that do things like data deduplication and compression, thinking about how they can get the most consolidation without increasing their risk profile beyond a level that they're comfortable with, and about making sure that they turn off old systems, right? So very often we find organizations deploy new, move everything to it, but they don't retire the old just in case we need it. Well, if you don't retire the old, you've just doubled your cost, right? So we have to get better at doing that. And that's definitely an area where we're working really hard to make sure that we help organizations remove the legacy, take out these ghost systems that are still running in data centers, just in case, or because no one really knows how they work or what they do. We've got to get that stuff out. That will make a far bigger difference than switching to photonics, for example.
Okay, and in terms of, provisioning, for example, what potential is there? I've assumed, because I've worked in the storage industry for 20 years, I assume everyone knows how to optimize their storage environment, but it would appear that's not the case.
No, it isn't.
And everyone, storage professionals traditionally got nervous, when the system's 50% full, they're thinking, we better, buy some more, capacity. But I'm guessing with whether it's the AI or whatever else it is you do, you can help convince them that they can maybe get, push the boundaries up to sort of 75, 80% before they need to start sweating too much. How much education still needs to be done there?
Loads. And interesting that you mentioned storage professionals, because in the very largest organizations, storage professionals probably do know that. But most companies don't have storage professionals. right? If you go to a bank or a central government organization, you'll find a team of them. Fantastic. They know what they're doing for the most part. They might not do things how you would want them to, but they do a pretty good job. But take the thousands of companies out there, or small public sector organizations who have an IT team of 3, right, who are trying to do everything from dealing with the laptop on the boss's desk through to the cupboard full of data center equipment the next day, or the hosting provider down the road who's got their data center facility for them. They don't know what they're doing, because you couldn't possibly expect them to have that detailed knowledge across everything that they have to do, right? Their job is to be experts in provision of IT for their business, and not necessarily experts in all the storage technology that's out there in the market to pick the right one for the future. And so I think the IT industry needs to get much better at supporting those companies and making sure that they're making the right choices. And that's on companies like Dell. It's also on the reseller community. We all have to get much better at not doing drive-by selling, and not, this is the latest and greatest thing, I'm going to sell it to you and then I'm going to leave you for 3 years. Actually selling them what they need and making sure that they're taking advantage of this new technology. So is it education? Yes, to some extent, but it's also a responsibility of the IT industry to make sure that we're doing the right thing by our customers every day.
Yeah, I suppose cynics would say there's a bit of a conflict of interest, because obviously the more inefficient your customer is, potentially the more you can sell him, because he doesn't realize that he could be using his existing kit better. But you're saying the debate needs to move on now to partnering them and helping them, optimize their environment.
Yeah, I think the days when you could get away with selling somebody more that they don't really need are gone, right? There's enough competition in the industry that we all have to do what's right for the customer. Because if you don't, somebody else will come along and point out that you haven't, and then your relationship is done. And I think it's incumbent upon all of us to do the right thing. And yeah, I think we're past that point now.
I'm just in sort of wrapping up. Net zero is bandied around and all over the place, but the data center industry, I think there are various commitments. 2030, I think, is one for a group, and then 2050 is the one that everyone's theoretically working towards. Are you optimistic that the industry is sort of capable of getting there and has the will? Do you think there will need to be a bit of a nudge from legislation, governments, etc.? Just how do you see that net zero? And is it even helpful to talk about net zero, or, as I say at the start of the conversation, should we first focus on optimization? And if that kind of gets us to net zero, that's good. But when you do the sums, as you've explained, all the great things you can do with digital technology, so you put them in the plus column and then you have the minus column with everything else, as long as it meets somewhere. Just your thoughts on sort of where we should be heading for.
So I think, as a general rule, if you're a data center provider, the more efficient you can be at provision of power, consumption of power within your data center, HVAC systems, whatever it might be, the more money you can make, or the lower the price you can charge and become more competitive. So I think there is a business imperative to efficiency in this space, right? And I think that ultimately will drive it. People's behavior is very often driven by how can I save money or make money, because that's my business. Now, there are things that should be done that probably do cost and don't necessarily deliver value. Those will be the things that we'll end up having to legislate for. And I think that will come unless public opinion and human behavior, or the climate lobbies, or however you want to describe it, starts to have enough of an effect that they just have to do the right thing. We'll see. But I am a great believer in the fundamental economics of efficiency actually is the right thing to do, and it will make you money. That will drive the vast majority of the change that we need in this space. And 2030 is what, 2 to 3 refreshes away if you work on a 3-year cycle, right? It's not that far. It's probably 4 generations from an Intel or AMD point of view, maybe 5. The roadmaps are already set out. We know what the infrastructure is going to look like, what it's going to need by the time we get there in terms of power supply and cooling, and what it will bring in terms of load. I think if most data center providers are smart enough to work out what they need to be doing and to get there on their own.
Okay, it's been fantastic to chat to you. So thanks for sharing your insights, Tim. Thanks for your time. Appreciate it.
Thanks, Phil.